Welcome to another tutorial. This session I want to talk about indeterminate limit using L'Hopital rule to solve the indeterminate limit. Start with this example. When we have a function x squared plus 2x minus 3 over ln x as x approaches 1, what you will discover is that you end up with 1 on the top and then 0 on the top, because if you put 1 into here, you got 1 plus 2, which is 3 minus 3, you get 0. And ln 1 is also 0. You remember ln 1, ln looks like this, ln x, and x equal to 1, y is equal to 0. So this is where it comes from. So you end up with a 0 over 0 problem, which is indeterminate. So we had to be able to figure out how to move forward from here. So in this case, I want to discuss separately. Oftentimes, the indeterminate limit is shown in the form of quotient or fraction. So suppose I have f of x is equal to g of x over h of x in this case. Say there is a value away from the x of x, the little gap in between. We can say it's very, very small gap, g of x minus g of c, where c is very close to x, and h of x minus h of c. So we can kind of make that assumption because it's so small that little tiny bit, even though in actuality probably it's changed the shape, but because it's so tiny, we'll make an assumption that it can be done. So then we can also continue to say that, perhaps we can also turn that into x minus c, make it very small, h of x minus h of c over x minus c. In this case, we can still kind of call it that way. But what we can also say is as limit as x approaches c to be very, very closer to c, right? We can say this, you have a limit of this whole thing, x approaches c for the top, x minus g of x minus g of c over x minus c, limit x approaches c, h of x minus h of c over x minus c. If you will notice that this thing right here is a small change of y over a small change of x, right? This is basically the limit definition of the derivative, right? And then on the bottom, this is the limit definition of the derivative on h. So in a sense, if we are looking for a limit as x approaches some sort of value for a function, but that function can be written as a quotient, then what happens is that you can do the same by doing the same thing for taking the derivative of each element of the quotient and then do the same limit to it. This is called the L'Hopital's rule. So if this is a L'Hopital's rule, let's see how this applies to a problem like this. So as we said, that this is 0 over 0, right? Doesn't work. This is the original function as x approaches c. But because the original function is written in a fraction or quotient form, indeterminate form is also in a quotient form, 0 over 0. Then what I can do is I can take the derivative of the top and then take the derivative of the bottom and apply the same limit to it. So let's try it. So let's take derivative on the top. We get 2x plus 2 divided by 1 over x and limit as x approaches 1. And in this case, we end up with 2 times 1 is 2, 2 plus 2 is equal to 4, and then 1 over 1 is 1, so our answer ends up to be 4. Now, it is interesting in a sense that if you graph this out, you will discover that this function together, taking it together, and then this function taking it together, derivative of the top and derivative of the bottom, and you plot it out on the graphing calculator, when they will land at the same place as you put x 1 into x. They will land at the same place, and this will be true for all these other problems. See you next time.